All right, so we're continuing our journey towards a better understanding of the base 12 version of pi by creating this diagram that generates all 360 degrees using base 12 geometry and the geometry of the dodecagon. So in the last video, I was looking a little bit closer at this pattern, which is basically the geometry of one unit of our circumference. And I was explaining how we want to also be able to turn it so that the circumference of the circle is also fitting between these two circles inside the larger circle. So what I want to do is go back to our first ring and just address that again more clearly, because it's an important detail to remember that the circumference is also the same thickness as the lines of degrees. All right, and so when we go back to that first ring of the diagram, we look at that first paragraph of information that I had, and underneath we have another little paragraph of information, and that's where I'm basically adding that 0.03 root 2 to our actual radius, and then I'm also subtracting 0.03 root 2, and that gives us the coordinates, the x-coordinates for those two additional rings that I'm talking about, because that's actually the complete process, is drawing our first radius of 3.2 root 2, then we add 0.03, get that lattice point, draw that circle, we subtract 0.03 root 2 from that, and we draw that circle, and then we calculate the, adding 0.5 root 2 to our center radius circle. We get that fourth ring, and then we draw that one, and that's the one that we position our small circles on. So for this very first ring, when you look at all those x coordinates, you'll notice that for this ring, the outside circle, the farthest outside circle is actually the one that is generated, I'm trying to think of the best way to say this, is generated from when we add the 90 degree angle of 0.5 root 2. So that our polygon is actually jutting out of the outside ring that's defining our circumference in this first ring. So if we look, sort of slide this over here and look at the x coordinates for the second ring, that now that the polygon is sitting inside of the circumference, the two rings that define the circumference. And then as we go to the third ring, we can see that those, like the gap between them is getting narrower, because again, those outside circumference, defining rings are always going to be the same. The center circle is always going to be in the center, but that fourth ring is always going to be getting closer and closer to the center circle that's in units of 3.2 root 2. So that's all I wanted to say, really, that the polygon is always getting squeezed into a narrower and narrower pair of circles. So that's basically it. I wanted to make sure that was clear.